Hello students, in this video we are going to start our new chapter called Algebraic Expressions. This will be part 1 of many parts that will follow. We are going to start with an introduction of this new concept with definition and some examples. Here in this figure we have a rectangle R1 of length 5 units and width 3 units. We are going to calculate the area of this rectangle. It means the surface that it covers, this pink surface. Remember, rectangle area equals length times width. So area of rectangle R1 equals length times width equals 5 times 3 equals 15 units. Now we have a rectangle R2 of length small l and width small w. Area of rectangle R2 equals L times W, or we can write LW. If we have a multiplication operation, we can remove the multiplication sign. Remarks. First remark, if between a number and a letter or between letters we have a multiplication operation, we can remove the sign times, but we cannot do the same for addition, subtraction, and division. So here, if you have a number and letter like 3 times a, we can write 3a. We can remove the times. Or if we have two letters like x times y, we can write it in the form of x, y. The sign times is removed to simplify the expression, to make it simpler, and in order for the expression to be written in a better and smaller form. Now let's do more examples. If you have a rectangle R3 of length 4 units and width 3a, or 3 times a. A is an unknown number. We don't know what is its value. Let's find the area. Area of R3 equals 4 times 3a. Now let's reduce it. How can we reduce it and make it in a better or smaller form? First, we multiply 4 times 3, it's 12. So we have 12 times a, we write it 12a. Here we have a rectangle R4 of width 2x and length 3x squared. Area of R4 equals width 2x times the length 3x squared. Here, instead of writing times, we can write 2x into 3x squared. When we put parentheses, it means 2x times 3x squared, or we can read it 2x into 3x squared. Into it means times. Now, how are we going to multiply these two terms? First, we multiply the numbers. 2 times 3, it's 6. Now we multiply x times x squared. X has as an exponent 1, invisible 1. We add 1 plus 2 is 3. So x times x squared equals x cubed, equals 6x cubed, or 6x exponent 3. And this is the area. Here we have a rectangle R5. Its length is 6m and its width is 5m. So here always the length is longer than the width. Area of R5 equals length 6m times 5m. Or we can write it like we did here. 6m into 5n equals, we multiply 6 times 5 is 30. Here m and n are different. They are two different letters. Here x and x squared these two powers have the same base x. Here no, m exponent 1 times n exponent 1. We cannot we cannot write them in the form of one power. We need to keep them m times n. So it's 30 times m times n, or we can write 30mn. It means 30 times m times n. But we can write it in this simpler form. That's, you see here, these expressions are written in a form that is simple and not complicated. That's why when we have multiplication, we can remove the multiplication sign. Now, let's start with the definition of an algebraic expression. An algebraic expression is a collection of variables and numbers grouped together using operations addition, subtraction, multiplication, and division. First, let's explain what do we mean by collection of variables and numbers. The word variable, it comes from the verb vary. It means changes. That's why we represent the variable by letters like a, x, y, m, n. These letters can have as a value any given number. And the numbers, they can be whole or decimal numbers, positive or negative. Example 3, negative 4, 5.8, negative 7.3. And fractions like 7 over 8 or negative 3 over 11. To understand this definition better, let's see an example. 3 times n squared minus 4 over 5 times m times p plus 2.4 is an algebraic expression. Why? Let's see. First, it's a collection of variables. Here we have 3 different letters, m, n, and p. Here, instead of writing m times n, we wrote n squared. And we have numbers. 3 is a whole number. Negative 4 over 5 is a fraction. And positive 2.4 is a decimal number. And they are grouped together using the operations addition, subtraction, multiplication, and division. Here, yes, we have a division. It's the over. Instead of writing 4 divided by 5, we can write 4 over 5. So here we have this expression linked by the 4 operations that we know, where we have also letters and numbers. Now let's identify the terms of this algebraic expression. How many terms are there in this algebraic expression? First, to identify these terms, we look at the addition and subtraction signs. Here we have minus, and here we have plus. Let's see what are the terms in between these two addition and subtraction signs. We have this term, 3 times n squared. This is the first term of this algebraic expression. The second term is this one here. But we shouldn't forget to also copy the minus sign, because in fact it's negative 4 over 5. Here it was positive 3, so we don't have to write plus. So the second term is negative 4 over 5 times m times p. And the last one, it's 2.4. 2.4 is the third and last term of this algebraic expression. So this is an algebraic expression with 3 terms. Each term we call it monomial. Later on we will explain its meaning. Remark, the addition and subtraction signs serve as separators between the terms of an algebraic expression. Now let's continue with the final part in this video, monomial. What's a monomial? Definition: A monomial is one term in an algebraic expression. Example, 3 times a cubed. This is a monomial. Why? First, we don't have any subtraction or addition signs, so this represents one term only. If you have one term only, we call it a monomial. So 3 times a cubed is a monomial. In the monomial negative 5x cubed, let's learn what are the parts of a monomial, what is a monomial formed of, what are the elements of a monomial. First, we start with the number, the 5. Here we have negative 5. Negative 5, we call it the coefficient of the monomial negative 5x cubed. Now, the letter, here we have only one letter, the x, we call it variable. This monomial has one variable, that is x. The exponent 3 is the degree of the variable x. So here we have a monomial with coefficient negative 5 with one variable x. Instead of writing x times x times x, we wrote x exponent 3. Remark, negative 5x cubed is a monomial with one variable, because here we have only one letter. Although the letter x, it's repeated 3 times, x times x times x, but here we have only one letter, so monomial with one variable. Let's see another example. Here we have the monomial 4 over 5xy squared. In this monomial, the coefficient is the fraction 4 over 5. Here we have two different variables. This is not a monomial with one variable like the previous example. This is a monomial with two variables. 4 over 5 is the coefficient. X and y are the variables. And 2 is the degree of y only, degree of the variable y. It's not the degree of x, because it's x times y squared. In order for 2 to be the exponent of x at the same time, x and y should be between parentheses. So be careful. So this is a monomial whose coefficient is 4 over 5, having two variables x and y, and 2 is the degree of the variable y. Remark, the monomial 4 over 5xy squared is a monomial with two variables. So this is the end of this video part 1. Thank you for watching.